Hello. Thank you so much for including me in the World Space Summit 2021. I'm really happy to be here. Recently on CNN, I was asked how Mars project can benefit sustainability on Earth and respond to the climate change.
Vera Mulyani is the founder and CEO of Mars City Design. She is building a prototype of what could be a sustainable city on Mars.
While a lot of my space comrades are certainly tired of the aggressive critics from general public about how space is a waste of money when we could use it to save Earth, well, I would like to use this opportunity to give a breakdown of the steps towards that achievement. Most of these technologies are already in the commercial market and have been used to develop the space missions, like clean energy, healthy supplements, eco-friendly materials. However, their stories may not be properly woven into the narrative of our space mission, and the technology push and pull are not well documented yet for the general public to realize their benefits are coming from all of this. So this technology push and pull that is in the cislunar mission architecture update from NASA a few years ago is what Mars City Design has been doing internally to advance our mission. We partner with existing tech companies whose innovations can be woven to our existing Mars City master planning. The reason why we are called the Mars City is so we can include all players who can build the city and not just a base on Mars. In doing so, we push their technologies to the next level to satisfy the Mars challenges and human wellness or crew safety focus. Rome is not built in a day, but out of Rome came great histories, cultures, innovations, and progress. So we hope the same version for our time when the pandemic, climate change, digitalization of our existences make our history today. So which part of master planning Mars can be useful for Earth today and for the next humanity's big leap? To build a base on the moon and to live in deep space on the way to building a Mars city and beyond? Well, we have been working on both the macro and micro scale architectures that will support not just the survival of the crew or the space tourists, but also their wellness enhancement while enduring these extreme environments. So first, these are the digital artwork we selected over the past 5 good years of Mars City Design competition. These macro scale visions involve the urban planning, imagining the possible cities designed to make sense of the Mars-based development, to not repeat the same mistakes on how industrial locations are developed on Earth, making the latter effect to the environment and inhabitants. These cities may be imagined today for the future, but some already demonstrate today's technology, leaning towards in situ resource utilization tool development that would be needed. This is not until there is the math that demonstrate how the ROI works better when sending 100 people over time instead of a crew of 6. Secondly, we did a class to study possible mission architectures. I'd like to give a shout out to my students who did these systems engineering projects at the Loyola Marymount University called Occupy Mars. One of the groups suggested to have uncrewed missions on Phobos and Deimos before a 6-crew Mars surface station operations. Another group suggested to use the service of a mix of NASA's partners, from SLS to Aldrin Cycler to Starship, to complete both Artemis cislunar stations and a Mars-based mission. And the other group did a trade study on only using the starships and other SpaceX rides, suggesting that the crew of 50 with a starship makes more sense economically, which in total, for Elon Musk's vision to send 1 million people by 2100 to Mars, would realistically be closer to 600,000 people. But yes, between these three groups, overall, it reflects how unless top economic countries can collaborate and chip in, both financially and technologically, we would have a hard time to achieve these humanity's big leaps, as the costs and risks calculated reach to a phenomenal level. If you're interested in learning more about what these students have presented in their finals, you can always reach out to me. Following the previous points, I'd like to share some Mars architecture ideas that involves using the local materials, ISRU, and locally grown biomaterial. This is our project called Alpha Hexa. From the selected Mars architecture submissions, we developed a project that promotes the poetry of the Martian dune landscape called Barcania Alpha. This is from Christina Cerdulo's team, project originally created by Kwanpo Cheng. Mars City designed and developed this project in the context of studying 3D printing on a NASA challenge in 2019. We 3D printed the shell with an exterior surface textured and inclined of 60° to accumulate the sand and to catch some dust storm deposits so that with time and the natural phenomenon of the Martian landscape, the structure could create itself some radiation and meteorite impact shielding, while providing a safe transparency on the facade on the other side for the view. The structure was designed to move once it reaches the maximum weight. This is a very poetical design that celebrates the natural challenges of Mars. Although we ended up only in the top 10 selection, NASA today is building a prototype that uses very similar concept and very similar name called the Mars Dune Alpha. On our end, we continued this project and experimented few other regenerative solutions beyond additive manufacturing. So with our partner, the Red House Studio, we recently built our prototype model on a scale of 1/25. We want to see how biomaterial could lead the next manufacturing technology industry. This is also to respond back to the CNN question about how Mars can help Earth. We are exploring mycelium, algae for the interior, and hempcrete for the exterior. Using these eco-friendly technologies, our Alpha Hexa presents new possibilities for living safely on the Moon and Mars, and the new ways to build on Earth that will ensure sustainability and accelerate climate change. So these are the pictures of our Red House Studio family testing the material and geometry structure resistance of just 1 meter or 3 feet wide model. In addition to being tough, heat resistant, and environmentally friendly, mycelia are regenerative and can survive in a wide range of conditions. According to recent research, these fibers could also be used to provide self-replicating radiation shielding. The step towards this can be an additional program for populating the market of cislunar economy, growing biomaterial in microgravity. In fact, we Mars City Design would like to reveal our collaborative project called Astrobiome. This is a platform to farming in space. This will start with our projects in micro scale. To accomplish all the previous visions, for humans to thrive on Mars, for us to be able to live in deep space, and the steps towards that, we realized that there is one step missing. Well, astronauts are selected from millions of extraordinary, out of this world talents. They are like Olympians, yet they are also vulnerable to the space environment. As we move towards space tourism, the question is, how can we make it so space is physically more accessible for lay people? We need practical solutions for humans to survive and to endure the extreme conditions during our trip to the moon, to Mars, and let alone to build the Mars city. So the missing piece in any analog space project is the human wellness focused tech. Among the most innovative technologies that exist today, very few can offer such scalable and reproducible solutions that can give significant impact for humans to thrive beyond just to survive. Without having to reach Mars yet, I realized that even aging on Earth is very challenging. We can learn from our friends in Japan, with their 40% of population having the longest life expectancy in the world, living beyond 60 years old, and the women beyond 87 years old. They show that our longevity expectation relies on our overall cognitive health, connected to our cardiovascular system, muscle strength, and bone loss prevention. It is the same challenge for Mars habitants. With our partnering lab in Tokyo, we have identified a microbiome advanced technology that has been successfully growing a rare microbiome originated from places that are also extreme. For example, a volcanic hot spring and deep sea level. These heat-resistant extremophiles microbiome offers an agri-tech design solution, keeping them alive even under a space vacuum with a high cosmic radiation rate, while requiring only little water and nutrition. Enhancing the human body has been a dream since humans tried flying, and my purpose is to bring practical solutions. This is the leap for humankind towards becoming multiplanetary. Our team at the Mars City Lab has identified that the secret to centenarians' longevity lies in their microbiome and their purposeful mindset. We will be launching a continuous cellular biology research that will advance humans' longevity development with the use of the ISS facility and other launch and hosting services. This Mars City Lab solutions will result the first Mars biofarming module ready to be applied to any farming systems in any harsh conditions on Earth, where we produce Martian superfood and grow medicinal plants that can promote humans' longevity and resistance to the extreme environment. Thank you so much for listening, and let me know if you have any questions. If you're interested in joining our efforts, we are looking to raise some funding for our astrobiome space projects that will be launching to the ISS next year, 2022.